warm front is indicated on the surface weather map by a red line. On the map, this line is only a few inches long and a fraction of an inch in width. But to you as a pilot, this small line represents the surface boundary of a large area of weather covering several thousands of square miles. In this region, flight operations are difficult because of low ceilings and restricted visibilities. The operational problems are further complicated by the fact that these conditions will remain over this area for many hours because the warm front cloud system is extensive and moves slowly. Flight operations are made more difficult during the winter months in this region due to the added hazard of ice. Flying in the area dominated by warm front weather is dangerous unless you know how to recognize and combat the many flight problems involved. In order to do this, you must be familiar with the cause and effect of the warm front weather. The warm frontal line on the map represents the surface boundary of a retreating mass of cold air. Friction slows the movement of the retreating cold air near the ground, and strong winds accelerate the air at higher altitudes. This causes the slope to be long and shallow. The warm air is lifted as it flows up over the cold wedge of air. This causes clouds to form, usually in stratified layers. They will spread out over the mass of cold air and may extend for a distance of 600 miles or more in advance of the front. Precipitation falling from these clouds causes lower clouds to form in the cold air underneath. The low clouds cause low ceilings, and the precipitation restricts the visibility. These conditions may cover an area 300 miles or more in width. The cold air is very shallow for a distance of 50 to 100 miles in advance of the front. It is in this region that the low clouds generally lie on the Earth's surface, causing the ceiling and visibility to be 0-0 due to prefrontal fog. Because the warm frontal clouds are usually in stratified layers, you can expect a smooth flight through them. However, scattered thunderstorms are occasionally embedded in the warm front cloud system. In this event, the expected smooth flight will turn out to be a rough one if your flight is not planned to avoid them. The warm front thunderstorms, as a rule, have higher bases and are less violent than those associated with the cold front, but severe turbulence can still be encountered in them. Therefore, they should be avoided at all times. They are a greater problem than those associated with the cold front because they are hidden by the other clouds. It is never advisable to conduct your flight at an intermediate level through the warm front clouds, for at these levels you are on instruments, and you might fly into the center of a thunderstorm unexpectedly. These local storms, which may be scattered throughout the warm front cloud system, can best be avoided by the application of one of two flight procedures. By conducting your flight at an altitude below 6,000 feet, terrain permitting, you will usually be underneath their bases, and they will be of little concern. Or by conducting your flight at levels of 18,000 feet or higher, the tops of the thunderstorms will normally be visible, and a course can be selected around them. When you approach a warm front from the cold air side, you can recognize its presence by the order in which the clouds precede it. The first indication of a warm front ahead is the white-banded cirrus clouds at a very high level. The cirrus clouds will be followed by a thin overcast of cirrostratus. The cirrostratus gives the sky a milky appearance and does not obscure the sun or the moon, but results in a ring appearing around them. As you approach closer to the front, you will observe a lower deck of clouds of the altostratus type. At first, the disk of the sun or the moon will be visible through the thin leading edge of this deck. They will soon be obscured, however, as the altostratus becomes thicker and the base lower. You will encounter precipitation when you reach a point where the base of the altostratus is some 8,000 to 12,000 feet above the surface of the Earth. In this area, non-uniform clouds, usually of the stratocumulus type, will be present at various levels in the cold air. You are now entering an area where instrument flight will be necessary. It is also at this point where the low clouds will lie close to the Earth's surface, resulting in low ceilings and restricted surface visibilities. As you get closer to the front, the precipitation will become more steady, and all the cloud decks will become indefinite and merge with each other. If in this area you encounter intermittent heavy precipitation, it is an indication that thunderstorms or heavy showers exist in the warm air aloft. As you continue your flight, surface conditions become worse. The ceiling will get progressively lower and surface visibility more limited. For a distance of 50 to 100 miles preceding the surface front, the ceiling and visibility will be near zero due to prefrontal fog. It is in this area that landings are often impossible due to zero-zero weather conditions. After you pass through the frontal system, the upper clouds will disappear. Weather conditions behind the warm front will vary with the characteristics of the warm air mass. Restricted ceilings and visibilities in the warm air are common in the middle and high latitudes over the open sea during all seasons of the year, and over continental areas in the winter months. This low cloud deck may extend for many miles out into the warm air. It may exist as postfrontal fog with zero-zero weather conditions when there is very moist air and light winds behind the front. When surface winds are strong enough to prevent fog formation, stratus clouds will be present. And stratocumulus clouds will form when there is turbulent mixing due to stronger surface winds. However, during the summer months, good ceilings and good visibilities are the rule behind the warm front over continental areas, and in low latitudes over the open sea during all seasons of the year. Whenever you make a flight into warm frontal conditions, careful consideration should be given to pre-flight planning with your weather officer. If instrument conditions exist or are forecast for your destination, you must be prepared to reach an alternate field. This procedure is essential since the ceiling and visibility at your destination may go below landing minimums while you are en route, and on arrival you may be directed to proceed to an alternate field. Ice accumulation on your aircraft constitutes a serious warm front hazard, especially during winter months. During this season of the year, the temperature in both the cold air and the warm air is vitally important to you. The general areas where you will encounter icing conditions are governed by the temperature. In a typical winter warm frontal situation, the temperatures of the cold air are generally below freezing. The temperatures of the warm air in the lower few thousand feet are above freezing, while temperatures at higher levels are below freezing. The clouds that exist in the warm air under these conditions contain moisture in different forms. Generally, these range from ice crystals at high levels in the clouds, where the temperatures are well below freezing, to water droplets at lower levels where the temperatures are above freezing. At a level where the temperature is about 0 degrees centigrade, the moisture will be in the form of water droplets, which will freeze upon contact with your plane. In the area where the temperatures are between 0 degrees and minus 15 degrees centigrade, the clouds are composed of a mixture of ice particles and supercooled water droplets. Because of the presence of water in liquid form at sub-freezing temperatures, this is the area where you may expect severe icing conditions. In the area where the temperatures are below minus 15 degrees centigrade, the clouds are composed mostly of ice crystals, and normally a light formation of ice will be encountered. However, the mixture of supercooled water droplets and ice crystals can exist in temperatures below minus 15 degrees centigrade, and dangerous icing will then result. Therefore, it is always wise to anticipate structural icing whenever the temperature is below 0 degrees centigrade. In the lower portions of the clouds, where the temperatures are above 0 degrees centigrade, no icing will be encountered. The type of precipitation falling from these clouds and into the cold air underneath is determined by the temperature of the warm air from which it falls. Under the area where the temperature of the warm air is above freezing, rain will fall. When the temperature of the cold air is below freezing, the raindrops will freeze as they contact your plane. This type of precipitation is called freezing rain. Under the area where the temperature of the warm air is below freezing, dry snow will fall. Between the dry snow and the freezing rain is a relatively narrow transitional zone. In the upper portion of this zone is a mixture of rain and wet snow. As this mixture falls through the considerable depth of cold air, it will freeze and become sleet. The precipitation zone under the warm front may be divided into two areas. In one area, freezing rain and wet snow are falling through sub-freezing temperatures. Ice will accumulate rapidly in this region, presenting a very severe icing problem. In the other area, dry snow and sleet are falling. Due to the fact that the snow and sleet are frozen, they usually do not adhere to your aircraft and will present no serious icing problem. In the warm front cloud system, therefore, there are two areas where ice accumulation is most dangerous. In the cold air, where the precipitation is in the form of freezing rain or wet snow, and in the clouds, where the temperatures are between 0 and about minus 15 degrees centigrade. If your pre-flight planning indicates a warm front lying across your intended course, recommended flight altitude should be obtained from your weather officer. The two most dangerous icing areas can best be avoided by flying on top of the clouds whenever possible. If this is not practicable and you find it necessary to fly within the clouds, select an altitude where less dangerous icing conditions exist. Low-level flight through this front, with freezing rain extending to the surface, should be attempted only when absolutely necessary, and only when the position of the above freezing air behind the front has been determined in your pre-flight briefing. Take the shortest possible path through the freezing rain to reach the warm air above it. In this way, you will minimize your flight time in severe icing conditions. In some warm fronts, weather data will indicate that the freezing rain area does not extend to the surface. In such cases, your best course will be through this above freezing area when safe terrain clearance can be maintained. When flying through the less dangerous areas in any warm front, ice may slowly accumulate. Therefore, if you fly in these areas for a long period of time, it can reach serious proportions. Whenever you plan a flight through a warm frontal area, it is advisable to orient your course so that you will go through at a right angle to the front, thereby remaining in the frontal zone the shortest possible time.